The proxy pattern provides a stand-in for another object to control access to it. The proxy sits between the client and the real object, acting as a gatekeeper. Picture an image gallery opening 8 high-resolution photos at once. Each real image reads its full file from disk right inside its constructor. Watch the loading 8 megabytes labels pile up. The gallery freezes on startup, even though most photos are never viewed. Eager loading hurts. What if we defer loading by hand? The image starts null, and before each display we check and load it if needed. But these null checks repeat everywhere, and the loading logic leaks into every caller. We define an image interface with a display method. Real image implements it, loading the file in its constructor. The client holds an image reference, not a concrete class, depending only on the interface. Proxy image also implements image, but stores only the file name. The first time display is called, it creates the real image, then forwards the call. That deferred load is the whole point. The client never knows which implementation it holds. Look at this class diagram. At its center sits the image interface, with a single display method. Both real image and proxy image implement it. Proxy image holds a reference to a real image and creates it only on demand. The client depends only on image, so proxy and real object are interchangeable. Look at these two versions. The first creates 8 real image objects at once, loading every photo from disk immediately, expensive and slow. The second creates 8 proxy image objects. Construction is instant, and the heavy load happens only when display is called. The gallery code stays identical because both share the same image interface. A proxy stands in for the real object behind the same interface, controlling when it's used. Benefits: lazy creation, access control, and unaware client. Variants: virtual, protection, remote. Client calls proxy, then real subject.